The Effect of the Standards of Mathematical Practice on Patterns in Algebraic Reasoning for Berry College by Kristen Stevens. My name is Kristen Stevens. I am a Bartow County educator for 19 years. I spent 13 years as a classroom teacher, primarily as math instructor. I have spent the last 6 years as a learning support specialist and an instructional coach. I have a master's in library media, and I have completed the Aspiring Administrators program in Bartow County with a goal of moving into administration. The problem of practice is the domain of patterning and algebraic reasoning. This was determined by analyzing the fall map data at my school. The third grade EIP room was identified as the area of focus due to their fall map scores. When I looked at their data, I noticed that 8 students scored below the 20th percentile on the RIT, or the Ready for Instruction scores, in the patterning and algebraic reasoning domain. 5 students scored in the 21st to 40th percentile range, and 1 student scored in the 41st to 60th percentile range, and that none of the students scored above the 60th percentile, which was the school improvement goal for all students to be considered proficient. I researched other strategies that had supported the area of patterning and algebraic reasoning. I studied schema-based instruction, Pictoria models, metacognitive strategies, peer tutoring, and multiplicative reasoning instruction. But I noted that there was a gap in instruction for the standards of mathematical practice. At the same time, we had a focus walk at our school, and one of our areas of improvement was to explicitly instruct in the area of the standards of mathematical practice. So I determined that the implementation of the standards of mathematical practice had a gap in research and in focus at our school. Therefore, my research question became, will direct instruction of the standards of mathematical practice improve student achievement in the domain of patterning and algebraic reasoning? I was going to use the third grade EIP classroom for my study because 57% of the students were less than 20% proficient in the domain of PAR. The control group was going to be the data we had collected from August to December with no SMP intervention applied, and the experimental group was going to be the data from February to May with the SMP intervention applied. The independent variable was the implementation and explicit instruction of the standards of mathematical practice. This is the intervention that would be applied for the study. The dependent variable was the math achievement in the domain of patterning and algebraic reasoning. This is the area that we hoped to improve. Some important definitions for the purpose of the study are standards of mathematical practice. These are the 8 habits of practice considered to be necessary for students in K-12 to be successful math practitioners. Patterns in algebraic reasoning, or PAR, the domain of math most closely aligned with word problem solution that is measured on the MAP assessment. The MAP assessment was the measure of academic progress, and the RIT score is a measurement system that ensures measurement is on an equal interval scale. The critical steps or actions to take for the research were to determine the problem of practice, using data to determine the area of need, completing the literature review to find the gap in the research, creating a timeline and weekly probes, beginning the intervention with the 2 selected SMP and co-teaching with a classroom teacher and applying the weekly probes, collecting and analyzing the data throughout the intervention period, and the final map data collected was in the spring of 2025. There was a mixed method data collection of quantitative and qualitative data. The quantitative data was comprised of the map data, specifically the PAR domain. The August data determined the need for the intervention, and the May data was the final measurement point. The weekly probes, They consisted of 4 problems representing PAR that will measure the growth and progress of the class as well as each individual student. And the student surveys. A pre and post student survey was about student opinion will be conducted and compiled into quantitative results. Qualitative data was comprised of teacher observational notes, which were logs from teacher observation of student response to intervention, and student interviews, which were random student interviews conducted throughout the intervention period to collect ideas and thoughts about the impact of the intervention. Progress and achievement results for the map data from the domain of patterns and algebraic reasoning. There was an average increase from the fall to spring map data score of 26.38 points. The mean increased from 172.45 to 198.83. The median increased from 169 to 191. The mode increased from 177 to no mode in the spring set since no number appeared twice. The fall range was 19 and the spring range was 28. The t-statistic was negative 6.18, which indicates the results were statistically significant. The weekly probe progress. The weekly average fluctuated, but the average consistently remained higher than the first week of 37.5%. The final average was 86.53. The class average increased a total of 49 points from the beginning class average. Students were given an opinion survey about word problems on January 10th and a post survey on May 10th. The questions with results of A and B were positive results, and C and D were neutral or negative results. The point of the survey was to increase the amount of A and B responses and decrease the amount of C and D responses from the pre to the post survey. The post survey results indicate no D responses, less C responses, and an increase in A responses. Observational notes indicate student growth in applying the intervention skills from the beginning entry before any interventions were taught, where it was noted that students were making several errors in their work and not applying to attention to precision, to the middle entry where students were beginning to apply attention to precision and modeling, to the final entry where students had taken ownership by applying the intervention and encouraging their peers to apply the interventions. Some of the key findings of the action research are that the standards of mathematical practice intervention proved to be statistically significant, with a t-statistic of negative 6.18, indicating that the two samples or means are 6 standards apart in PAR for the MAP spring test. This results in a small probability value of less than 0.05, indicating the results of the study are unlikely due to random chance. Also, the weekly probe average increased 49 points over the SMP intervention period. Some limitations of the study are that a larger sample size of students could provide more comprehensive data, and that the intervention period began in the second part of the school year when a full year of implementation could have benefited the students for a longer time. Implications for future study could prove that the results could be important for educators who want to impact the area or domain of PAR, and that educators could consider applying small group interventions with a wider scope than the 2 standards of mathematical practice that were used for the study for greater success. Personal application of the action research resulted in increased curriculum knowledge for the researcher, content knowledge using the standards of mathematical practice in context, improved instructional coaching, improved knowledge of data analysis, and personal growth through developing connections and learning more about myself and how I want to lead and teach.